Hi everyone, in this video we are going to talk about angular velocity or omega. This is not W, it's an omega. Omega is a Greek letter. We use it to represent the angular velocity. Angular velocity tells you how fast an object is spinning on a circle, whereas linear velocity tells you how fast an object is moving forward. So the average linear velocity is displacement divided by time. The measuring unit for this is meters per second. But angular velocity equals the angular displacement divided by time. The measuring unit is going to be rad per second. And as you can see, the two equations are very similar. Now the equation that connects linear velocity to angular velocity is this equation. Linear velocity V equals the angular velocity omega times r, the radius. Whenever you have an object spinning, the angular speed is the same everywhere on a circle. However, the linear speed is not the same. So let me give you an example that will show you this. Let's say this is the center of the circle, and this circle is spinning at 10 rad per second. Let's say this is point A, and this is point B. As you can see that the radius of A is smaller than the radius of B. Point A and point B, so which one has the greater angular velocity? Point A or point B? Now because the wheel is spinning at one angular speed, every point on this wheel, including A and B, are traveling at the same speed. So they are making the same angle at the same time, or they are making the same number of rotations at the same time. So they are rotating at the same rate. In this case, omega A equals omega B. So the angular velocity of point A is equal to the angular velocity of point B. They are going to rotate at the same rate. Now, what about the linear velocity? Is it the same or is it different? Now they are all spinning at the same rate, but point A has shorter distance to travel. Point A is covering this circumference. Point B has longer distance to travel, right, at the same time, which means that point B must move faster than point A in order to cover this greater distance in the same time. So the linear velocity of B is greater than the linear velocity of A. And from the equation, we see that V equals omega R. In this case, omega is the same, 10 for A and 10 for B. So what about VA and VB? If we know that RA, let's say 2 centimeters, and RB is 4 centimeters. In this case, VA will equals 10 times, we need to convert it from centimeters to meters. It's going to be 0.02 in meters, and the radius of B is 0.04 meters. In this case, VA will be 0.2 meters per second, and VB is 0.4 meters per second. Now there's some other terms that you need to know, and that is the period and the frequency. The period is the time it takes to complete one cycle. So if you have the total time and the number of cycles or rotations that the object will make, so the total time divided by the number of cycles gives you the period. It's measured by second per cycle or second. So if you are going to divide the total time by the total number of cycles, you get the time it takes to make one complete cycle or one full rotation around the circle. Frequency is the reciprocal of period. So frequency, it's the reciprocal of period. It's the number of cycles that occurs per second. So if you have the number of cycles and you divide it by time, this will give you the frequency. The unit for frequency is hertz, or 1/second. And sometimes it's written like second minus 1. It's the same. Now period is 1 divided by f. You can also calculate the angular velocity if you know the frequency and period. The angular velocity equals 2 pi over t. And this, if we have an object that's going to rotate or make one complete rotation, its angular velocity equals delta theta divided by delta t. In this case, delta theta, in case of one complete rotation, will be 2 pi. And the time it takes to make this one complete rotation is the period, p. So omega equals 2 pi divided by t. Also for frequency, f equals 1 over t and t equals 1 over f. So in this case, if we are looking for the omega, or for the angular velocity, and we have the frequency, we can use the following equation. Omega equals 2 pi f. And this comes from omega equals 2 pi over t, 2 pi over t. Instead of period, I will put 1 over f. And this will be like this. Omega equals 2 pi divided by 1 over f. This equals 2 pi, and instead of division I will put multiply, and I will reverse the position of denominator and numerator of this fraction, so it's going to be f over 1 or f. So omega equals 2 pi f, or omega equals 2 pi over t. This is the angular velocity. Thank you.